it's really important to be able to calculate the enthalpy change of a reaction, as it's often found in examination questions where energetics is being asked about. Here, I've taken an exam question from a June 2012 AQA Chemistry 2 paper. They're asking you here to calculate the value for the standard enthalpy change of the synthesis. And the synthesis we're interested in is this one here, where carbon dioxide and hydrogen are reacted together to form methanol and water. And synthesis is just another word for the word reaction. Okay, what are we going to use? We're going to use the standard enthalpy change of formation to be able to do this. Okay, so that's our information. The examination paper also gives us values for enthalpy change of formation. So carbon dioxide has an enthalpy change of formation of minus 394 kilojoules per mole. Hydrogen gas, by definition, as it's an element, is 0. Methanol was minus 201 kilojoules per mole, and water is minus 242 kilojoules per mole. So the first thing I'd be interested in doing is trying to write out a Hesse cycle. So this reaction, these reactants and products are derived from their elements. So carbon dioxide and hydrogen are derived from elements carbon and hydrogen and oxygen. That's how we find these elements in their standard states. The carbon, the hydrogen, and oxygen can be used to form our reactants and our products. Before we carry on, which is really important to note, that we need 3 moles of hydrogen for the reaction to actually proceed. So either the reaction to form the reactants or the reaction to form the products. And the direction we're interested in going in is from the reactants all the way to our products. And this is what we call a Hesse cycle. Now, before we proceed, we should also relate that this is the enthalpy change on the left hand side, the enthalpy change of formation of our reactants. And on the right hand side is the enthalpy change of formation of our products. And we can use our reactants and products to come up with a completely new enthalpy change of reaction. So the enthalpy change of the reaction, and call that R, equals the sum, because we're going to add all the enthalpy changes, and because the arrows here are going in the same direction, the sum of the enthalpy change of formation of our products take away the sum of the enthalpy change of formation of our reactants. So let's start putting in the numbers. So in our products we have methanol and water. Let's quickly scroll back up. Methanol has a value of minus 201 kilojoules per 1. And we also have in here water, and water, as I said, has got a value of minus 242 kilojoules per mole. And we're now going to take that sum away from the following: the value for the enthalpy change of formation for the reactants, which is going to be minus 394 plus 3 moles of oxygen, which has got a value of 0. So if we carry on, that's going to give us a value of minus 443. Minus a minus becomes a plus 394. And if we take this away from that, we will end up getting a value of minus 49 kilojoules per mole. So where are the marks in this paper? Well, the first mark you're going to get is for correctly stating that the enthalpy change of reaction equals the enthalpy change of the products take away the reactants. That's your first mark. The second mark is for putting the numbers in. And the final mark is coming up with the correct answer. Now, the sign is negative because of the way we've written out the answer here for the Hesse cycle. It's the products take away the reactants. Products take away the reactants. If you've got a value of plus 49 kilojoules per mole, you'd lose a mark in your examination paper.